Okay, guys, so we are now looking at the lesson 13 problem set, and our direction says find the area of the following rectangles, draw an area model if it helps you. So in the previous video, we had two ways of solving. One was we used the area model and the distributive property, and the other way was we used fractions greater than 1. And we multiplied those. So before I even start with the problems, I'm going to look at what I'm multiplying. For question A, we're doing 5/4 kilometers times 12/5 kilometers. So I think to myself, okay, do I need to do an area model like that? Knowing my multiplication facts, 5 times 12 is 60, 4 times 5 is 20. I'm dividing 60 20ths. Okay, I can do that using fractions greater than 1, which is what these are. Okay, so if we're multiplying, this is 5/4 times 12/5, which is going to give us 60 20ths. Sorry, you guys, I said draw an area model for that one. We know when it's already in this form, we're just going to multiply. 60 20ths. 60 divided by 20 equals 3. Therefore, our area is 3 kilometers squared. So you can see in a problem like that, that shows that it's easier to do it this way. So let's look at another problem. So I'm going to travel on down to problem D. So I want to look at these. So I have 7/8 miles times 4 1/3 mile. So I want to think about multiplying these. Now, I could do an area model, but 4 1/3 is the same as 13/3. And yeah, I might have to do a little division, but I think this one still might be easier if I turn this into a fraction greater than 1. So we're going to do 7/8 times 3 times 4 is 12 plus 1 is 13. 13/3. Okay, and that's going to give us, now I can't do 13 times 7, but I can do 2-digit by 1-digit multiplication fairly easily. So we're doing 13 times 7. 7 times 3 is 21. 7 times 1 is 7. Plus 2 is 9. So we have 91 24ths. And now we do need to turn this into back to a mixed number. But again, this division, I can think of 24 if I counted by 20s even. 20, 40, 60, 80. Oh, that means it could go in 4 times. But this isn't quite 20. It's closer to 25. So if I'm counting by quarters, 25, 50, 75. But if I add another 25, I'm at $1. That's more than 91, right? 100 is more than 91. So that tells me this can go in 3 times. And so now we're going to figure this out. 24 times 3, 12. 3 times 2 is 6 plus 1 is 7. So we end up with 72. So I need to subtract that from 91. And guys, I'm just following all the steps we've learned with fractions. So none of this is new material. We've learned it. Okay, I can't subtract 2 from 1. I'm going to come over here to the tens. This becomes 11. 11 minus 2 is going to be 9. So that leaves me with 19. So 3 and 19 24ths becomes our mixed number. And so now we're going to have area equals 3 and 19 24ths. Okay, and if you're saying, Mrs. Ponte, no, that did not seem easier, then solve it. Get a piece of paper. I hope you already have a piece of paper and you're working these with me. solve it using an area model. See if you liked that better. You get to decide how you want to solve these problems. Now, for problem B, 16 times 4, I already know that's going to give us a pretty big number. And if I turn this into an improper fraction, that's 21/5, 33 halves. I'm having to multiply 2-digit by 2-digit. I don't want to do that, so I'm going to draw an area model. 16 and my half, 4 and 1/5. And I'm going to do my multiplication. I need to do 16 times 4, right? Because this is going to be 16 times 4 plus 1/2 times 4. So I think we just did this on the other problem. 64. Okay. So 64 plus half of 4 is 2. So this is going to equal 66 meters squared. Now I'm going to do my bottom. So I'm doing 16 times 1/5 plus 1/2 times 1/5. So this is going to give me 16/5, which is going to be, 5 goes into 16 3 times. 3 times 5 is 15. So if I subtract that 15 from 16, 3 and 1/5 plus 1/10. Right? Okay. So I still do need to do a little work because I have fifths and tenths. I know that 1/5 is equal to 2/10. So now I can add this to 3 and 3/10. I'm going to take my 66 meters squared. I'm going to take my 3 and 3/10 meters squared. I'm going to add those together. 66 plus 3 is 69. We have 3/10 meters squared. So we did have to do some additional work, but I still think this was easier. At least it was for me. But you're going to decide which strategy you want to use. Okay, so I'm going to actually jump down. I'm not going to do problem C. You can definitely write down problem C and solve that on your own. But I want to take a look at this word problem. So here we are. Julie is cutting rectangles out of fabric to make a quilt. If the rectangles are 2 3/5 inches wide and 3 2/3 inches long, what is the area of 4 such rectangles? So we need to identify what our question is. What is the area of 4 such rectangles? The area of 4 rectangles is, and we know we're working in inches, is inches squared. Okay, so we have to go back into our problem. We know she's making a quilt. Okay, great. Quilt. All right. So we know that the rectangles used in this quilt, so this is, I'm going to draw while I'm reading. They're 2 3/5 inches wide. Okay. And 3 2/3 inches long. So I know I'm multiplying 2 3/5 inches by 3 2/3 inches. So again, you can decide at this point, do you want to turn these into fractions greater than 1, or do you want to use an area model? I'm going to use an area model. I feel more comfortable in some situations with that. So we have 3 2/3 for length, and then we have 2 3/5 for width. Okay, so now I'm going to solve. 3 times 2 plus 2/3 times 2. 6 plus, I can see that this is going to be 4/3, right? 4/3. I know that 4/3 is equal to 1 whole and 1/3. So here we have 7 and 1/3. Right? Yeah. Okay. Did I write that down right? Did I miss something? 2/3, 3/5, 2 and 3/5, 3 and 2/3. Okay. I just needed to check. All right. So now down here, we're going to have 3 times 3/5 plus 2/3 times 3/5. Okay, 3 times 3 is 9. This becomes 9/5 plus 6/15. Okay, but now I kind of notice something. My denominators. Thirds, fifths, 15ths. 15 is my common denominator, so I'm going to rewrite this down here. 7 and 1/3 plus 9/5 plus 6/15, because I need to make these into like units so I can add this together. So I know that 1/3 is the same as 5/15. So 7 and 5/15 plus. I know that 9/5 is going to be the same as 27/15. And then I have my 6/15. So when I add those all together, I'm going to end up with, let's see, 27 plus 11. So 27, 37, 38. I'm feeling like I may have made an area in 20/15. I feel like I made a mistake somewhere. Oh, hi, buddy. Can you give Mama a minute so she can finish? Yeah, give Mama a minute. Okay, so yeah, Mrs. Ponte doesn't know what she did right here in this problem. For some reason, I'm checking my work real quick to see if I made a mistake somewhere. Did I not? Okay, 3 times 3/5. Let me do it like this. 6. This was 4/3. I'm going to keep that in that form. 3 times 3/5 was 9/5. Sometimes it's good for this to happen because then I need to, and 6/15. I'm getting a different answer than the book and I'm not quite seeing. Oh no. Okay, wait. What did I say this was? 33/15, 27 plus 11, 27, 37, 38/15. So 7 and 38/15. 15. Oh my goodness. Okay, Miss Ponte is being crazy right now. Okay, 38/15. Let's do this up here. 15 goes into 38 2 times. 2 times 15 is 30, which is going to leave 8/15. I'm going to add this to my 7. So my total becomes 9 and 8/15 inches squared. That's the area of a rectangle. But we're using 4 rectangles. So we actually now have to do 9 and 8/15 times 4. And again, we're going to use that distributive property. We're going to multiply this 4 by 9, and then we're going to multiply this 4 by 8/15. So that's going to look like this. 9 times 4 plus 8/15 times 4. Okay, 9 times 4 is 36, plus 8 times 4 is 32/15. Here we have again an improper fraction. 15 goes into 32 2 times. 2 times 15 is 30. That leaves 2/15. I'm going to add together this and this. And, okay, and the area of 4 rectangles is 2. Sorry, guys. This is what happens when you have a 2-year-old running around, is 38 and 2/15. So this becomes our answer up here from inches cubed. 38 inches cubed. Okay, thank you for staying with me. I had a little mind meltdown in part of this problem, but worked through it, saw where I was making errors, realized I didn't make an error. I just needed to continue on. So I hope these help. Watch the videos, do your Zern lessons. All right, thanks. Have a great day.